Okay, so this is note 6.2, page 3, and we just covered a problem where I gave you a factored one and asked you for the zeros or the roots, and this one just simply turns that process backwards. So I'm going to tell you that this one has x-intercepts at -5, 3, and 7. So we have zeros at 3, -5, and 7. That means that this one here is the result of setting this equal to 0. And what you simply do is you back up. If the x equals 3 is your answer, you take this back over and you go x minus 3 is what would zero that out, and you've got your first one there. You do the same process with the next one, x equals -5. And if you take this back over the other side, you find out what it was that you were zeroing out. In that case, x plus 5 is that middle factor. And a factor of 7, these are easy because all you do is change the sign when it goes over. Okay, let me write it down. X equals 7 is the last root or x-intercept. And if you bring that over, you find out that x minus 7 must have been the factor that generated that root. So here it is. Now, the tricky part is it tells us that we have to get this expression into standard form. So I'm going to write it down again, and we're going to do all the work it takes to get this in standard form. X minus 3 times x plus 5 times x minus 7. Usually I leave the first factor alone for now, and I'll FOIL out the back. X squared, and there's a 5x minus 7x. I'll put minus 2x and combine those, and minus 35. And now you take the x times each of these, so that gives x cubed minus 2x squared minus 35x. And then you take a minus 3 times all of these. So that's going to be minus 3x squared. I'm lining them up here. Plus 6x. And finally, 3 times 35 is 105. So add these all up and you'll find the function. It's f of x equals x cubed. That's the front one. I've got these off, but this pair here is negative 5x squared. Sorry, I'm not lining them up very well here. These are negative 29x plus 105. Okay, so you could check this. What you would do is type this in your calculators after you store some random number for x. Then you type this in also, and the results should match if you've done it correctly. Okay, so what do you do when there's a fractional result? Well, one way to do it would be to set up fractions and you just change the signs. But that's not a very good way to do it, because if you were trying to FOIL this out and get the other thing, you'd have just a mess. You got fractions times additive fractions. It just would be a total mess. So this way of doing it here, I don't like. Instead, you're going to find these factors that led to this answer by just backing up. I'll show you what I mean off to the side. So the first one is x equals 3/5. If you multiply both sides by 5, you get 5x equals 3, and then take the 3 back over, and you get 5x minus 3 equals 0. This is this factor down here. And you do the same process with the other ones. I'll do them both here. So it says negative 1/2. If that were equal to the x, you multiply both sides by 2. And take the negative 1 over, and you'll get your 2x plus 1 is what you were trying to zero out, and you've got it right there. Okay, so we've got all of these out, and if it asks for it, you'd have to multiply it all out to get standard form. But there's your answer, and you can maybe see this one here. Now, a shortcut is pretty easy. The number on the bottom, let me get a smaller pen here. The number on the bottom goes in front of the x, and the number on top goes behind it, but you have to change the sign of that one. So for instance, this one has a 3 on the bottom, 3x, and a -8, so we'll put +8. Okay, and you could ignore the rest of the stuff here. It just shows you that the x-intercepts are the same for both approaches, and usually you don't care how tall the graph is, so never mind that part. Okay, and this is page 4, and we'll continue this on the next video.